Recently, our client Tommy met his banker to discuss continuing his father's restaurant legacy. In us, he found a partner that understood the importance of passing the torch. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy.
Attention, all Go Guns enthusiasts! Have you seen what Sarge has released recently? These new models and attachments are sure to excite you. Outfit your desk with these meticulously crafted gun models, guaranteed to exceed your expectations. We'll buy them back up to 100 days. Don't miss out on the opportunity to add these stunning pieces to your collection. Visit GoGuns.com now to see our new releases.
This is SpaceTime, Series 26, Episode 51, for broadcast on the 28th of April 2023. Coming up on SpaceTime, the mystery of fast radio bursts deepen, the Tongan volcanic explosion, now regarded as the biggest in over a century, and China launches more spy satellites. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A mysterious blast of energy from the dark reaches of deep space has astronomers scratching their heads. The blast was a fast radio burst that seemed to be coming from a dynamic binary star system, but the data doesn't add up. Fast radio bursts are sudden ephemeral blasts of radio energy, usually lasting just a nanosecond or so, but releasing more power in that time than our sun does in an entire year. The explosions occur at very specific wavelengths, usually at cosmic distances in the spiral arms of galaxies, often billions of light years away. The first was detected back in 2007 in data from the Parkes Radio Telescope in the central west of New South Wales. Since then, hundreds more have been detected. Ultra-bright flashes of radio energy all over the sky, hundreds of times a day. Some flashes last just milliseconds, others over a second, and they can span a wide range of radioluminosities. The first bursts were all singular events, occurring just once at a specific location, and then never again. That suggests they may have been caused by some sort of cataclysmic event, such as a supernova or exploding star. But astronomers are now detecting many fast radio bursts that are repeating from the same location, and that suggests a very different origin. The leading contender is a highly magnetized neutron star called a magnetar, but feeding black holes and glitching neutron stars haven't yet been ruled out. The different types of FRBs, or fast radio bursts, means there could be two separate sources for these mysterious deep space blasts. Or it could simply be that all fast radio bursts are repeaters, with some simply repeating a lot more often than others. The truth is, astronomers are still struggling to try and make sense out of it all. But now a new study in the journal Nature has cast a new light onto the debate by providing a treasure trove of data for one specific repeating fast radio burst known as FRB 2020-1124A. Meanwhile, a separate study in the journal Nature Communications suggests a possible cause for this repeating burst's behaviour. The problem is the two studies aren't matching up, and so the debate continues. The multiple bursts coming from FRB 2020-1124A were first detected by CHIME, the Canadian Hydrogen Intensity Mapping Experiment, back in 2020. 91 hours of follow-up observations were then made using China's massive FAST, or 500-metre aperture spherical radio telescope. The authors detected some 1,863 bursts over 54 days. That represents the largest sample of fast radio burst observations ever recorded from a single source that included polarization data. The polarization data is important because that allows astronomers to determine the strength of the magnetic field and the density of the plasma near the source. But surprisingly, they found that either the magnetic field or the density near the fast radio burst source kept changing, and the changes were occurring within timescales of just a few days. To explain these strange observations, the team writing in the journal Nature Communications, which included two of the authors from the Nature paper, suggested that the fast radio bursts were being generated in the region around a magnetar where a strong magnetic field dominates. But they also say the magnetar must be in a binary system with a massive spectral type OB blue star companion, a very specific type of extremely luminous blue star which has a circumstellar disk of gas, making it a BE star. They suggested the magnetar's violent supernova birth probably caused a kick, sending the orbital plane and the disk plane into misalignment. And so as the pair orbit each other, radio bursts from the magnetar sometimes pass through different parts of the blue star's disk, thereby creating the fast changes being observed. And it all sounds very plausible. The same sort of thing had been seen before in another system containing a BE blue star, this time with a different type of a neutron star called a pulsar. And yet another fast radio burst with similar properties could also be explained by a system with a BE blue star companion. The problem is, FRB 2020-1124A doesn't appear to repeat regularly, as would be expected in a binary system. So the team decided to observe the fast radio burst's host galaxy using the giant 10-meter Keck telescopes upon Mauna Kea in Hawaii, and they discovered a metal-rich barred spiral galaxy very similar to our own Milky Way. The fast radio burst was spotted erupting in one of the outer arms, a long way from the galactic core, and not usually an area known for young stars such as OB blue stars. Jonathan Nally, the editor of Australian Sky and Telescope magazine, says the best way to make headway in solving this puzzle is to capture more data on the fast radio burst, including a multi-wavelength, multi-messenger and multinational approach, where scientists can bring together the observations of many different teams and telescopes in order to challenge the theory.
It's been a topic that's been around for quite a while now because scientists couldn't figure out what these fast radio bursts were. A fast radio burst is something, I think it's anything that lasts between 3 milliseconds up to 3 seconds. Just a burst of radio waves from something somewhere out in space. And because they're so brief, you have to be looking in the right direction at the right time with a radio telescope in order to be able to pick it up. So they've actually designed systems now that are always on the look for these things so that they can pick them up and try and then identify where it's coming from exactly in space. So they've been trying to pin down the origin of this phenomenon, and for a long time no one really knew what produced them. Then some observations, as you said, seem to show that a kind of star called a magnetar was the culprit. A magnetar is a neutron star with a particularly intense magnetic field. Not all neutron stars are like this, but magnetars are. It's a neutron star with a really intense magnetic field, and a neutron star itself is just the squashed core of a star that has exploded. It's sort of one step removed from forming a black hole. But now, some scientists are not so sure that the magnetar idea is the complete picture or even whether it's right at all. That's because some Chinese scientists have studied a particular magnetar from which fast radio bursts have been seen and found that the magnetic polarization of the radio bursts varied on very short timescales, on the order of days. And what they've come up with to explain this is that they think there might be another star, a young star, orbiting around the magnetar, and the bursts of radio waves that are coming out of the magnetar are sort of passing through some of this other star, going straight through it, and thereby end up getting changed. The polarization changes as the radio waves go through this companion star. Sounds pretty good. Scientists think that's a reasonable scientific explanation, but other astronomers are not so sure. Because you see, this particular source of fast radio bursts is located in a somewhat emptier area between two spiral arms in its host galaxy, sort of like the back blocks of this particular spiral galaxy. And these astronomers say that this is not the kind of galactic neighborhood where you would actually find either magnetars or this proposed young companion star going around it. You would think that you would find a magnetar and young stars in parts of a galaxy where it's more star dense, more stuff going on, rather than sort of the outskirts of the back blocks. So if that is the case, then this thing that they're getting these radio waves from is not a magnetar, and then perhaps magnetars are not the answer for these fast radio bursts, or maybe not for all of them. And so it seems that it's back to the drawing board again. And having said that, I mean, there's no agreement on this. So some people say this and some people say that. So we don't know which is right or whether both are wrong or whatever. So looks like fast radio bursts are going to hold their mystery for a little while yet.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is SpaceTime. Still to come, the Tongan volcanic eruption, now believed to be the biggest volcanic explosion in a century, and China launching more spy satellites. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Scientists have now confirmed that last year's Tongan volcanic eruption was the largest natural explosion on the planet in over a century. In December 2021, a series of eruptions began on Hunga Tonga Hunga Ha'ape, a submarine volcano in the Tongan archipelago in the southern Pacific Ocean. Hunga Tonga Hunga Ha'ape is 65 kilometres north of Tongatapu, Tonga's main island, and is part of the highly active Pacific Ring of Fire. The eruption finally reached its massive climax nearly 4 weeks later, on the 15th of January 2022, with a mega explosion so powerful it could be heard thousands of kilometres away in New Zealand and Fiji. It generated shock waves that could be detected 500 kilometres out in space. That's higher than the orbit of the International Space Station. The explosion had a volcanic explosivity index, or VEI, of at least 5 and was described by scientists as a mega hammer, resulting in the largest volcanic eruption since the 1991 eruption of Mount Pinatubo and the most powerful eruption since the 1883 eruption of Krakatoa. At its height, the volcano produced a series of 4 underwater thrusts, displacing 10 cubic kilometres of rock ash and sediment, and generating the largest atmospheric explosion ever recorded by modern instrumentation. The eruption also caused mega tsunamis, with waves up to 45 metres high along the coast of Tonga's Taufu Island and waves up to 17 metres on the main island of Tongatapu. Tsunamis also struck Fiji, American Samoa, Vanuatu, and right along the Pacific Rim, including New Zealand, Japan, the United States, the Russian Far East, Chile, and Peru. The new analysis, reported in the journal Science Advances, uses a combination of before and after satellite imagery, drone mapping, and field observations collected by scientists to produce a tsunami simulation of the Tongan archipelago. The results showed that the complex shallow bathymetry of the region acted as a sort of low-velocity wave trap, capturing a more than hour-long tsunami with waves up to 85 metres high, 1 minute after the initial explosion. The study's lead author, Sam Purkis, from the University of Miami's Rosenstiel School of Marine Atmospheric and Earth Sciences, says while the eruption rivaled the 1883 eruption of Krakatoa, which killed more than 36,000 people, it claimed far fewer lives. Despite its size and long duration, the mega tsunami that resulted from Hunga Tonga Hunga Ape claimed just 4 lives because of its location, the COVID-19 pandemic, which was keeping people indoors, and increased evacuation drills carried out by Tongan authorities in the years prior to the eruption. The study also suggested that the eruption's location relative to urban centres saved Tonga from a worse outcome. But Purkis warns that while 2022 may have been a lucky escape, there are lots of other submarine volcanoes which pose the capacity to spawn future tsunamis on a similar scale. He says this eruption holds important lessons for both past and future tsunamis in Tonga and beyond. This is SpaceTime. Still to come, China launches more spy satellites as it continues its preparations for war. And later in the science report, new warnings about the dangers of artificial sweeteners. All that and more still to come on SpaceTime. China has launched a new constellation of Earth-observing satellites aboard a Long March 2D rocket from the Taiyuan Satellite Launch Center in Jiangxi Province. This new constellation is different. It consists of a central 320-kilogram pivot satellite and three 270-kilogram assistance satellites. All are equipped with interferometric synthetic aperture radars, and the combined network is sensitive enough to detect geological changes at millimeter levels. The mission came just over a week after the launch of a Kuaizhou 1A solid-fueled rocket from the Jiaquan Satellite Launch Center in the Gobi Desert, carrying 4 weather satellites into orbit. 2 days earlier, a 4-stage Long March 11 solid-fueled rocket was also launched from Jiaquan, this one carrying the classified Qian 19 spy satellite into space. The clandestine spacecraft was placed in a 580-kilometer high orbit. Meanwhile, China's just launched a Long March 4B rocket carrying another weather satellite, the Fengyuan 307, also from Jiaquan. Beijing now has an estimated 624 satellites orbiting the Earth, including over 266 Earth observation, surveillance and reconnaissance satellites, including at least 47 Go-Feng and some 112 Yaogang spy satellites. This is SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study using data from more than 300,000 people has found that vitamin D deficiency may be causing premature death. The study involved a technique called Mendelian randomization, which uses genetics to allow scientists to determine whether one thing causes another rather than the two just being linked. Researchers from the University of South Australia found that the risk of death decreased steeply with increasing vitamin D levels, up to recommended levels, and the biggest effect was in people with severe deficiency. The authors say more research is needed in order to identify strategies that will reduce premature risk of death associated with low vitamin D levels. A new study warns that artificial sweeteners should no longer be considered as a healthy and safe alternative to sugar. The findings, reported in the British Medical Journal, are based on a large study looking at artificial sweetener intake and health. Scientists looked at dietary intakes and consumption of artificial sweeteners, as well as other health and lifestyle factors, for over 100,000 French adults. They found that total artificial sweetener intake was associated with an increased risk of cardiovascular disease. A new study shows when it comes to teen dating violence, boys are more likely than girls to report being the victim of violence, either being hit, slapped or pushed. That's the surprising finding of new research reported in the Journal of Interpersonal Violence. Scientists analysed data from 3 British Columbia adolescent health surveys involving 35,000 youth at grades 7 to 12 who were in dating relationships. They found that overall, fewer teens are experiencing physical abuse from their dating partners, with 5% of teens reporting dating violence, down from 6% a decade ago. However, the researchers found 5.8% of boys, as opposed to just 4.2% of girls, said they had experienced violence during a date in the past year. The researchers now need to understand why boys are reporting more dating violence than girls. If you're a police detective or investigative journalist, then you already have a wealth of experience, resources and background knowledge to help you separate fact from fiction. And if you still support the fiction after that, then you're either stupid or corrupt. But how does the average person separate fact from fiction? Or whether a conspiracy theory has any validity, or it's just propaganda to push a particular viewpoint? Tim Mendham from Australian Skeptics says there have been lots of studies and guides on the subject, and now a new one presents a simple 10-point plan.
Conspiracies pop up all the time. Sometimes they're justified. A lot of times they're not. A lot of the times they're just sort of there to explain why horrible things happen to you. So naturally, no one can say, oh, that's just bad luck. They have to say, well, it's them that did it to me or them that are doing it to society, whatever. So a lot of conspiracies fly around. They have for hundreds of years. They're flying around better these days because they've got social media to spread through. But they're much the same nature of things. A group or a industrial military complex or a group of politicians or whatever you want to know have been plotting to rule us and run the world. And one of the things that crops up a lot is, of course, the secret information about vaccines, COVID vaccines actually hurting people. Someone wrote an article fairly recently called the 10-Step Guide to Sense-Checking Conspiracy Theory Claims, using the recent example of 32 Canadian doctors who died at an early age, and asking, is this proof of a problem with vaccines? Now, presumably because they're doctors, they have had vaccines, and presumably they've had more than one. So he gives these rules for what you should look at, using this example, but more broadly applicable. So one, you evaluate the reliability of the source, if it's coming from the net, if it's coming from some person who's a rat bag or some continual campaigner against vaccines, you assume it's got that particular sort of line of approach, line of argument. You look for other sources. If you see the same wording repeated, that just means they're copy and pasting. So you look for something that's independent. The third aspect is looking for ground zero, which is what's the basis of the claim. You try and find where it originally came from.
The scientific journal or medical journal, whatever.
Yeah, medical journal will be one thing. Someone on the net and on their podcast or on their website, etc., is probably not necessarily the best sort of source
Unless
to go
it's
to.
Me.
Unless it's you, of course. Yeah. Space. Your thing is definitely on the good side of things. But someone who has a particular axe to grind might not be the best person to take evidence from. Okay, then you look at the motives. Why are people doing it? Obviously, conspiracy theories are to explain things that they're doing to me, and it wasn't my fault, it was them, and therefore you look at sort of why they're sort of saying these things. Then you evaluate the claims individually. You look at them and say, is this correct? Did these things actually happen? And truth of statements made in the conspiracy theory, are they just generalizations or do they actually have some basis in fact? And that means you look at a sixth element, which is contextualizing the claims, seeing how they fit in with these 32 Canadian doctors. How many doctors would die at a young age in Canada? And there's close to 100,000 doctors in Canada, so a fair number of them will die early and die young. In fact, this article points out that they probably didn't die of vaccine poisoning, which is what the conspiracy theory is saying. In fact, there should be more than 32 who have died. Have you just chosen out these 32 because they sort of fit your preconception? People die all the time, unfortunately, and a lot of people die young, but these ones they talk about, some of them were up in their 60s, so it's not that young. So therefore, it's cherry-picking evidence. It's not giving enough context to what these claims are. I've heard other things, theories put forward about these person died young because they had a vaccine and the vaccine injury, etc., caused them to die, especially COVID vaccines, they're saying. And some of the examples they use are so far out. I know at least one case where someone died in a car crash. Their death at a young age is cited as being a vaccine death. Then again, you hear people who die in their 80s or 90s, and they also say, well, that's a vaccine injury. So, excuse me, they're old and people die. Seventh point, you look at the consistency of the data set, and does it apply over a whole period of time? Look at the bigger picture, in other words, and see if there is a theme running through this or if there is not. You look for questionable assertions, in other words, sort of outrageous claims, outrageous phraseology. You come down to do what this article calls a plausibility smell test. If it smells off, it probably is off. If it seems dodgy, it probably is dodgy. A claim that is too good to be true probably is not true. So you just look at it you stand back a bit, you think, does this make sense? But does it sound a bit dodgy? Who's the person telling me, etc.? And then you ask an expert, if you can. You ask someone who actually knows what they're talking about and doesn't have a particular axe to grind and see what they think. So there's 10 steps to going through conspiracy theories, from looking at the source, looking at the data, the evidence being put forward, how is it phrased, does it make sense, what is the truth of it within a context, are they just cherry picking out a particular bit of data, does it smell off, and what do the experts think, rather than the person on their blog, I'm an anti-vaxxer.blog, sort of thing.
And that's really a good philosophy for life when you think about it.
It is. I mean, it's basically critical thinking. Critical thinking says, I want to look at the evidence before I make a decision. I'm not going to just leap in.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.